Okay, before we jump into it, though, I do want to take a minute to introduce what's going to be the next big thing in web development. It's pretty astounding, actually. Well, let's just jump right into it. For those who can't necessarily see from the back, that is the CPAN homepage from circa March 1999. Now, that seems sort of ridiculous. How is that the future of the web? You know, how is that hypermedia? How is that REST? How is that anything beyond just the same old web development that we've been doing? But I'm actually serious about that, because if you look at what that document was and what was being served there, it has everything that a modern hypermedia RESTful system has. It's got a dedicated hypermedia type. In this case, it's HTML. The communication sent from the server to the client is sent over HTTP using the standard HTTP verbs. In that case, get and post. The data that's sent contains embedded discoverable links to not only resources directly related to the data that you're looking at, but there are also links to additional metadata. If you look in the headers, there's an author's link. Excuse me just one second. So there are the links that you see on the page, and there are also additional links in the head of the document telling you, for example, the author of the document. If you look at the raw payload that's sent over the network, it's meaningful not only to the dedicated client meant to interpret it, in this case, an HTML web browser, it's also comprehensible by human beings. There are embedded comments. You can get a general sense of the structure and meaning of the document by looking at the source. Those are all elements of what makes a modern RESTful web API. So if that's the case, if we've been doing this for 15 years now, if those elements have been in place for 15 years, why is web programming still so hard? Why are people still making web frameworks? Why is it still, why isn't this just, an invisible part of the infrastructure? Well, part of it is that we invented and reinvented and have reinvented and reinvented new things instead of just using what HTTP had to offer. Now, that's not really, I'm not trying to place blame, but you have a practical problem to solve. Early browsers supported get and post, and that was it. So you had to limit your conversations with the server to those two HTTP verbs, even though the full range of HTTP verbs have been there since HTTP 1.1. We overburdened the things we did use. We used post for everything. If you want to send any kind of data to the server, you want to make any sort of change, well, you send a post. Well, you could, why not send a delete? Well, the browsers don't support it. Why invent all of these extra layers to do data validation when we could just send a different media type to give some kind of hint about what data was coming across the wire? Well, the browsers don't really support doing that. Why do we build these complicated systems that, break out every little step in the URL and build this hierarchy of classes? Well, because that's the one concrete thing in the system that you can grab onto. And so it sort of makes sense. You grab a hold of what's predictable and reasonable and grow from that. We applied some of the wrong design patterns. During the early days, we realized that just sending a mess of HTML over the wire, tied up in print statements, made for unmaintainable systems. So we decided, let's separate things out. Separation of concerns. Well, we want the data model, we want the business logic, and then we want the format that's going to be served. Unfortunately, I think it's natural to say, well, we have this problem where everything's bundled together and we want to separate them out. Let's reach for this existing pattern, model view controller, and apply it to the web. Unfortunately, that particular pattern is terrible for the web because the type of entities that exist and the types of communications that exist between a web server and a client don't really match up to model view and controller. You can sort of wedge them into that space. It was still in advance over a bunch of CGI print statements, but it came with a pretty heavy cost. So, where does that leave us now? There's lots of talk about what makes a RESTful system, what is hypermedia, where are web APIs going. Everybody's inventing, this sort of path dispatcher and that sort, once again, reinventing the same sorts of things, but really making RESTful systems is not much more than just using all of HTTP. And that's even the best documentation about REST always mentions the word constraint within the first two paragraphs. It's always presented to users as a set of rules, a bondage system that, well, you're not RESTful unless you're throwing this specific correct error code under these circumstances. And yeah, you want to be able to do that, but it sort of gives the impression, if you go on Stack Overflow and look through the REST threads, that it's sort of this legalistic bondage system that is absolutely no fun whatsoever. And in my opinion, that's absolutely the wrong way to look at REST. To me, REST is nothing more or less than using HTTP, using all of HTTP, and not inventing something new when HTTP already does what you need. So, you use the full range of HTTP verbs: get, post, put, delete, patch, etc. The full range of status codes. There's more to life than 200 OK or 404. You can actually say something meaningful to the requesting client by what sort of error status code you throw. There are HTTP headers, link headers that can point to other resources, e-tags for providing, cache identity, among other things. The whole range of custom headers that you can embed into your documents to communicate whatever it is that you need to. You don't need to invent some crazy new system for doing that type of communication. The infrastructure is already there. Media types. This one's a big one. You're not limited to what a browser can necessarily process. Or, there's no reason, there's nothing stopping you from making a new media type that uses XML or JSON or something else as its data transfer format. But by declaring a separate media type and on the server side saying, this is what I'm going to emit and this is what I'm going to accept, then a lot of the, well, what did I get? And what am I going to send? Questions that we invented all these intricate solutions to suddenly go away. So that brings us to HATEOAS. HATEOAS is the acronym for Hypermedia as the Engine of Application State. Really, it's not this great, those people who do REST will mention HATEOAS as if it's, some sort of magic formula for doing, it really is a cool thing, but it has this almost mystical aura. But it's really not all that complicated. The root of HATEOAS is don't make the client have to guess or know ahead of time where to go from their current state. If I send you a chunk of JSON that represents your shopping cart, that chunk of JSON should include links to that the client can understand to where to go through to purchase that, where to go through to cancel that order, where, what interface to go to add another item to that order. Don't make the client guess. Don't rely on out-of-band documentation to fill that gap. There's no reason not to embed it into the document itself. Think about HTML links and forms. We tend to look at that. It's like, well, that's not the real data coming back, but that is the essence of what hypermedia is. Here is this structured bit of text with a predictable meaning that will tell you that there is something related to this resource in some way that you're going to be interested in. And a web browser knows enough when it sees that to present you, a bit of highlighted text or whatever that you can click on to follow. In that case, you've got, the interpretation is a combination of the client that knows how to present it to you and you as the user that knows that if you see the blue text or whatever and you click on it, that you will be taken to that next resource. It's the same way with forms. What it's actually sending you is a control for sending data back to the server that isn't, arguably at least, related to in some way to the representation that you're currently looking at. Custom media types are especially useful here, where you want to be able to, you want the ease of, let's say, of using JSON for transferring data back and forth, but you want to be, you want to be able to know ahead of time that the data that is coming to you will have the elements and the type of structure that you need. Now, declaring a media type doesn't automatically make that data conform to that, but you can sort of, part of it's social. If somebody knows enough to be posting, let's say, well, we'll look at a different format here. Post, collection JSON media type, that they're also familiar enough with that media type to then, to know how to structure that data that they're sending. Yeah, we'll look at that. That all sort of sounds abstract. So, let's look at a particular example of that type of media type. So it's the hypertext application language. Simple and lightweight, comprehensible to both humans and automated clients. Associated, if you go and get that order, you can choose in how you build that representation, how you want to frame associated and dependent resources. You've got that order, it's got a customer object. Sometimes it's going to make sense to present that as a link that if the client needs to, it can follow and go and get the customer data. In a lot of other situations, it makes more sense to embed that customer data directly in that, to embed that into the order itself. Neither one of those is right or wrong. That's always going to be dependent upon what's going to be easiest for the client, what makes most sense for the application. And by predictably pulling those two elements out, saying this is either a dependent embedded, another embedded object, or the link to go and get that object, you can be clear that the rest of the data that you're at the top level is actually part of the order that you're looking at. And it's available in both JSON and XML. There's the link to follow if you're curious about that. We're actually using this, or a modified version of it, on a project right now, and it's working out really well for us. So this is what it's reasonably self-explanatory. You're looking at a list of orders. This is a representation of a collection of orders. At the top level, there's always going to be one element in the links field, which is the link to yourself. You never have to try and construct on the client, where did I get this data from, what API, there's no string munging. And every object you get back, you know exactly where to go back if you've got changes for it, if you need to ask for it again, if you need to check on the status, whatever. Then you have the embedded key. Here, we've got, 2 orders? And, each order itself, the data contained by the order, is relatively simple. The total, what currency, and what the status is. But each one of those also has, again, the same set of links and this is an important part about this, each time you descend into an embedded object, the context resets for the links. So you don't have to worry about, well, wait a minute, I'm at this order, and that order has a customer, and that customer has an address. That address, the URL, the self address, is always going to point to just that address. You don't have to worry about managing the link all the way back up the chain. Questions about this before I go on? Because I feel like I sort of rushed through it. This is an example of the JSON that you get back if you make a request for a collection of orders. So you've got the link at the top that points back to, just /orders. That is going to be this collection of orders. If you request again, if somebody else placed an order, it will change. But in this particular representation, you've got the next link relation. Not exactly. I mean, it's just it's named href just because that's sort of conventional, that we know, that that's going to be, a hypermedia reference, that it's going to be a link to something else. And there are actually other relations that you can define inside those links, like a human readable title and things like that. But the href is the only one that is absolutely required. Any other question? Okay. So all of these things that have made the web hard, the ways that we've tried to work around stuff, the things where we've gotten too clever and overburdened things or left easy things lying on the table, we are symptoms, I think, of one common problem. And for those of you unfamiliar, this is Roy Fielding. He's why we have the word rest. That's his invention from his dissertation. And he talks about this problem on his blog quite a bit. A resource is not the thing that is transferred across the wire or picked up off the disk or seen from afar while walking your dog. Each of those things is only a representation. Rest itself, the R&E, is a representation state transfer. When you send a request to the server for that collection of orders that we just looked at, you're not asking for the data in the database. You're not getting back the resource for that information. You're getting a representation of that resource. And I think that's where a lot of the confusion comes in, and why, especially like rest over CRUD and those types of systems, end up being so troublesome to deal with, because it gives the impression that the resource is this database table, or the resource is this row is in that database table, or it's this block in this NoSQL store, when really it's not. That's just the data that informs the resource that you're asking for a representation of. What lives at the end of that URL is not the resource. It's the URL is just a place to go and ask for a representation. Or as a different thinker said it a bit earlier, the resource is not the thing. Ce n'est pas une resource. It's, of course I'm going to take the opportunity to show a bit of surrealist art if I can, but the name of this image is the treachery of images. And I think it's sort of cute to show this, as an illustrative point, but I think there's also something profound in it. We look at that data that comes back from the server, and we think that's the resource. We look at that database table and think that's the resource, when it's really not. It's just a representation. The resource is a bit more abstract than that. You're never going to get back or interact with or deal with the resource itself. You're only going to get a representation of that. So, no, that isn't a pipe. It's a painting of a pipe. Or in this case, it's a slide with a picture of a painting of a pipe. So, with me so far? Good. Yes. It's important because when you start thinking about that, let's say you're doing, a CRUD-based REST interface to a database table. If you think about that table as the resource, then you start tightly binding your API to that table structure. I think that this is where Rails goes off the rails. They look at, the steps in the path as ways to get into these classes and lists of methods. And that tight coupling, that mistaking of the representation for the resource leads to all sorts of craziness. And it makes the first day of the project easier, and every day after that a lot harder, because you think, okay, well, the resource is the database table, so I want to do a post to that, and I'm going to add a record. Well, the database schema evolves, and as always the case, tables don't live in isolation. So now you've got to make sure that, for this order that you're going to take, that the customer ID is valid. Well, if you've tightly coupled your API to the database table, where does that logic go? Well, every system has its own way of doing that, but, suddenly now that nice little, hey, I didn't have to touch anything. I just, loaded my database table with whatever, Catalyst controller REST or whatever, just to, not picking on them, just as an example. And, now where does that validation happen? Do you have to build it into, do you build it into the controller? Does it go into the model? Is it an event that suddenly that super simple, well, I just, added it, and look, Instant Web API starts to break down. And it break down quickly, and pretty soon you start wondering why you wanted to do the stupid REST thing in the first place, because it's clearly just a pain in the ass. I think that, as much as anything, is the practical distinction of and it's tempting. It's I do it myself even still, where you start treating that object that you're dealing with as the resource, and well, I can't do that because if I do that, that's breaking the validity constraints of that object. No, all that's ever being interacted with is a representation of that resource. So there's nothing wrong. There's no rule that you're breaking. Like, for example, in adding, embedding links and embedded data in the orders that we looked at in that example. If you take the view that each one of these orders is the thing, then all of that starts, the links and the other information starts to feel like out-of-band information because it's not part of the thing. It's not part of the resource. But that order isn't the resource. It's just a representation of the resource. And I, as the client, want to include into that representation the other ways I can change state on that particular representation of that resource. So it's not seeing the resource is not the thing, is the way to get out of that tight coupled trap that makes most REST systems difficult and unpleasant to deal with. Okay? Sure.
You also say that it's really useful to have one visual layer of interaction so that rather than a common example I could draw from Smalltalk is that everybody seems to want to make accesses for every one of their instances are automatic.
Right.
And in fact, what all you're basically doing is turning an object into a protocol with a hat, which is silly. You really want an object to have interfaces, and then who cares that it's implemented inside the box?
Right.
Are you
Absolutely. Yeah, it's that tight coupling that always gets you into trouble.
Yeah.
Okay, anybody else before I move on? So what's my big solution? Why are people crazy for implementing all of these new RESTful web frameworks? Well, my solution is a new RESTful web framework called Magpie, built specifically for resource-oriented development. I think using Model View Controller was a step up from what came before it, but I think it's showing its age. And I think people are really starting to get hip to the fact that it is and always was cramming a square peg into a round hole. And it's also part of where the resource is the thing fallacy comes from. Because, well, the database is the model. So it's the model that that's the thing that I'm operating on over here. But it's not true, and it's never been true for the web, that data that you're going and ask for, that representation that you're going to ask for is the thing. So when you start, so it's partly a model, You know, what's a resource then? It's partly a model, it's partly a controller. The view may even influence some of those things. So, you know, it's not a good fit, and it's, you know, cramming a square peg into a round hole. Magpie is built specifically to be resource-oriented from the beginning. It uses an event-based processing model. Excuse me, I'm parched. By that I mean that it follows some prior art in both Unix-like operating systems, a previous web framework I worked on called AxeKit, the Apache 2.0 server model, the idea that, you know, nothing tries to be everything by itself. You know, rather than having one tool that does everything, you build a bunch of little tools that do one thing well and string them together. And this is a little bit about how things work. You know, in a pipeline model, the configuration determines which components, which of those little workers get added, and then the components themselves decide which of their events are going to operate on that particular representation. Implemented via Plaque middleware Magpie. So it's, you know, it's Plaque middleware. It'll play nice with, and does play nice with, all the other Plaque middleware out there. Right. This is, I mean, I could make a smaller example of a Magpie app, but this is about the smallest useful one. Most people familiar with Plaque? Show of hands? Okay, that's pretty good. Don't want to get too far off into a PSGI tutorial, but you know, essentially, you're using Plaque Builder, you enable the Magpie middleware, and it has a member called the pipeline, which, oddly enough, is how you pass it the pipeline. In this case, you're getting one component, Magpie transformer XSLT, and define a static definition of which style sheet to use. Now, notice we've got another middleware enabled here, the standard static file middleware, which points to the same document root and limits it to XML files, because you really don't want to try and apply XSLT to a GIF image. So, single pipeline component. The resource data, every pipeline, whether you explicitly define it or not, gets a resource class. If you don't define one explicitly, there's Magpie resource abstract that will look to see if there's incoming data from any upstream Plaque handlers and creates that as the resource data for the current pipeline. Every other component in the pipeline will then have access to that data. And in this case, that will take an XML document that someone requests from inside the document root and applies the style sheet hello.xsl style sheet to it and sends it off to the client. You know, like you could make a simpler one, but I mean, that implements about 50% of what AxeKit and Cocoon did. Dispatching. Now, when I say dispatching, and you hear dispatching, if you're familiar with REST, we're probably talking about two different things. Because if the first thing you thought about was mapping a URL to a series of classes and methods, then we are definitely talking about two different things. I think that's one of the part of where of why modern popular REST systems are problematic. The URL path is only part of the equation. In Magpie, dispatching happens at two levels. There's which components will be loaded into the pipeline, and then which event methods within those components will actually operate on the data to help do something to the incoming request, help build the outgoing response. So let's look at loading components first. Pipelines are defined in the configuration. We saw a bit of the DSL here. You've got a Perlish DSL, or you can do it as an external XML config. Rather than having an embedded pipeline directly in that, you can just say enable Magpie conf and a pointer to the XML file on your file system. There's a good reason for that, which I'll go into later. So there are several options for deciding which components get loaded. You can do like the one we saw. There was a static pipeline. You declare the pipeline, you put one component in it, and you're done. Dynamic pipelines use the machine keyword and one or more of the match options. It'll look similar to like the URL match, Plaque middleware, but it does quite a bit more than that. And we'll see in a second here. Components are added from top down in configuration order. So we'll see why that matters here. Dynamic pipelines are loaded using the machine keyword. And inside, we saw the pipeline before that just had one component in it. Here we've got a machine. And, the first test is if it matches, beginning of the string, API cast member, it will load, my app resource cast member into the pipeline. And if it matches API prop, it adds the prop resource to the pipeline. In either case, or in both those cases, it will add my app serializer JSON. So whichever type of resource you're dealing with, when if you post something to the cast member resource, it will do whatever it needs to do, and then the next stage in the pipeline will create the JSON representation that gets sent out to the client. That's kind of a mixed pipeline. You've got part of it that's dynamic, and then part of it that's static. In addition to the simple match keyword, which takes either a regular expression or a literal string, you've got match template, which is also a regular expression match, but also allows for URL template like curly braces for capturing param value pairs that get stored and then passed along to each component in the pipeline. So you don't have to go through, if you do a lot of REST stuff, it's like, okay, well, which step am I at? Is this the ID for the container that I'm operating on, or is it the ID for the thing? Is that 3 steps over? You don't have to do that. You can say in your configuration, API prop curly braces, object ID. And then when you get to that resource, you can say, give me the URL param object ID. Oh, I've got one. Well, then I know I'm operating on a specific one, as opposed to a collection of them. And if you've ever tried to implement a REST interface, and that's, well, wait a minute, there's no ID. Is there a / Is that a collection? Should I just send them an option? I mean, it's, makes things a lot easier, believe me. Match end, which takes a similar syntax, but rather than taking a URL path, the second argument is an anonymous subroutine, which is past the Plaque environment hash. So you can go through and say, if you need to examine a series of custom headers, or what HTTP method was used, or what the media type was. You've got a way to go in and examine those things as the request is coming in to say, load these components or don't load these components. And then there's match accept, which adds one or more components based on a content negotiation matrix. If you've ever worked with HTTP negotiate or dealt with content negotiation, like in setting up an Apache server, you can say, I've got this list of things. that the client will send an accept header or any number of accept headers with with quality ratings that's compared to a matrix that you set up in the configuration, so that it makes things easier. For example, if it's not this is good, or what I've found it especially useful for is doing conditionally loading components based on the incoming media type. You can send send a post from or a get from jQuery on the client side saying, I want collection JSON, and on the server side you can say, oh, it's asking for collection JSON, so add this collection serializer that will just take the object that you got, but then wrap it in a particular way that that fits with what the client is expecting. So that's how you determine what components get loaded. Once those components are loaded, each one runs in turn. It's a linear pipeline, and each component controls its own dispatching. This is another part of where I think most frameworks sort of go wrong. They get one idea that works really great for one type of thing, and then try and apply that same event model to every problem. But the reality is that if you're doing this sort of component-based framework, you want your we'll look at some of the different types of event models here in a minute. But the most logical way to implement a resource class is to base it upon the requested HTTP verb. That's not the same as what the event model is going to look like for something that transforms that data using XML, or like the collection transformer I talked about before, where it takes one or more objects and formats them in a particular way. So each there's what components gets loaded, the match rules, and then each component can say, there's dispatch a request method, which is at the heart of all the Magpie's resource classes. If somebody, what's the resource? I got, the request method is a get, so that immediately drops into the sub named get in that class, and that's where you do your business to construct the representation. There's Magpie dispatcher request param, which basically on the cheap gives you the dispatch magic model for CGI application. And you don't often have to, but it's easy enough to roll your own. You write your event methods, register the methods that you want Magpie to know about, and then implement a load queue function that is past the full request, the upstream resource, or, well, not in the case of the resource itself, but a number of other predictable members that you can then examine to determine, of the events that are registered in that class, which one of them should fire. So do I really need all of that on every project for everything? Absolutely not. But the idea is that, so much time is wasted, I think, and you pick one thing that works so great for this solution, for this problem, for this problem, and this problem, but then there's this problem, and it doesn't really match up. I would rather have a framework where I can do this, and this is different over here. Well, no big deal. I just use a different event model. So will you use all of that stuff on every project? Absolutely not. But you will use some of it in each of them. So I'm just one of those people that would rather have more than less, more options than fewer. So here, enough with the blah, blah, blah. I'll look at a little bit of code. Here's what a simple resource class would look like. Again, notice that it inherits from Magpie resource which runs on the request method dispatcher. And in this case, we're going to show the implementation of get. You could easily add in post and put and all of the others. In this case, it's kind of a toy example. You go and grab the data from, the secret method of, however you get your widget data and some arguments. Unless you get back that data, throw a 404. Otherwise, you squirrel the data into yourself as the resource class and return OK. Now, the reason you do that second to last step is that every other component in the pipeline has a resource accessor that will give you back this resource class. So if it needs to get at the data, it can just say self-resource data. And so, you're transforming XML, you just grab, self-resource data and do the transformation. Or if you need to learn other things from the resource class, like, particular serializers or really anything that makes sense to implement on the resource class that your other components will also need to know about. All of those components have access to it. So if there's no model like an MVC and the resource is not the thing, then where does stuff go? And the answer is in the assets. Each Magpie application has a breadboard container where you can put the things that you need to do, to do that business, rather than baking your resource, your API right up next to the database table. You can add, the connection logic into the breadboard container, and then your resource can just say, self-resolve asset, and then the service name of your database handle, and there's your database connection. You don't have to, that same asset is available to every component in that pipeline. That part in particular has been pretty revolutionary in how we develop stuff. Being able to separate out those sorts of logical, practical dependencies from the code that actually, implements the resource that creates the representation, and not having to bind them so closely together. Being able to put them in one centralized store that all of the components can pull from has it's like having this supercharged configuration. Rather than passing around the same connect string and configuration args, you can just set up the database connection once, declare it a singleton, and you're done. You can ask for and get that that connection every single time. It's really been great. But wait, there's more. Existing Plaque middleware classes can be used as pipeline components. You've got some cool Plaque middleware that you want to use, and you're in the middle of something, and man, I really wish I could use that, but I've got to do, I've got the resource class here, and I've got the other transformer there, but I want to generate the E tag right here in the middle before that transformation happens. Well, you can add the E tag middleware right there in the center. Component classes and their event methods have full access to the pipeline. It's a fully controllable state machine underneath the hood. So if you get to a point where you've got this long pipeline and you're in the first component that's checking the validity of the data coming in, you don't want to run the rest of the pipeline. You can say, nope, wrong media type, and from your event sub, declare done, and that short circuits the pipeline. You can also dynamically add other components, change the order of the components, again, maximum flexibility. And as I said before, each component-based class has a predictable set of convenience attributes for getting at the request, getting at the headers, getting at the response, getting at the resource that, that was at the center of that request. Also, all component classes are trait aware, which is really useful if you're doing more configuration-based stuff. You can make more generic components and then mix in traits at runtime to implement the specific behaviors that you need, rather than having to subclass and do a bunch of changes. You can, write a quick roll, throw it on there, and say, now apply this trait. So that's a sort of scattered introduction to Magpie. What's there? We've got a solid, stable, tested core. I've been working on this for more than a year now. We've done 3 fairly major projects with it, and it's stable. I was telling Chris the other day, I've been working on the front end of the application that I'm working on now. I just had a sort of crappy little plaque-up demo instance running as I was working on some of the front end stuff, and it had been running for 2 weeks, and I hadn't had to touch the back end of it. So pretty stable, pretty solid. Test suite's actually pretty good. Workable APIs for the various common component types. Resources we looked at, there are transformers, like with the XSLT we saw, plugins for the traits interface, the dispatchers for you can make your own event models if you need to, but I think over time there's going to be a growing list of, I like the way CGI application does things, so I'm going to implement that, that dispatching event method. I like the way this other framework does that. It's, whatever makes the most sense for the common use cases that come up. But the APIs are there, and they're pretty reasonable. There's a small but growing number of general components. KyokuDB is what we use a lot at work, so that's probably the most mature of the generic resource classes. The file resource is also pretty good. XSLT, template toolkit, transformers, stuff like that, those are all there. A committed core of developers. We are Tamaru. We're putting a lot of faith and a lot of stock and a lot of time and a lot of hard work and a lot on the line to make sure that this succeeds. This isn't a toy project for us. We're not going to go away. If other people start using it, that's great, but we will stay using it. What's missing? Docs. I had planned to. Right now, Magpie is not on CPAN, although it is on GitHub, and I had planned to release it for this talk. But the reality is that I couldn't put it up there with a clear conscience and then point people at it with the documentation in the state it is now. What you've learned in this talk is considerably more sophisticated than the existing documentation, and that's just sad. I feel like I wouldn't be being a good member of the community if I put something out on CPAN that was like that. I know that there are a lot of other people that disagree with that position, but that's sort of where I'm at with it. So docs, many more generic component classes. It taps away on the back of my head that there's not a DBIX class resource, DBIX resource class. There needs to be one. I can see the code in my head, but we're too busy working on stuff using Magpie for me to, just to be able to take that time and do it on a flyer. There are different styles of web applications, and because much of the configuration and component stuff is because of so much of what drives it is configuration based, what I want to have is bootstrap profiles for general common, I want a CRUD REST interface, I want a brochureware site, rather than baking those things into the code and, and putting the cart before the horse. I'd rather have a script or a class or a series of scripts to be able to say, I want this type of thing, here are my classes, iterate over them, and generate me the resource classes and what the configuration looks like. Something that you can start with. Don't make things easier. Make that first day easier in the way Rails does make that first day easier, but then don't lock them in, lock people into each day after that being harder. The Magpie GUI. The goal of all of this, my eventual nirvana for Magpie, is that there's enough generic components and enough bootstrap profiles that you could essentially stand up a working, functional, non-toy REST API through a browser-based GUI. And that's part of the reason that from the beginning, I insisted on having the XML config. It's not just because I'm the XML guy. It's because I think it's much easier to generate that sort of thing and manage that sort of data that, now I've got this configuration, it's just, there's little or nothing that you have to write by yourself. It's just a matter of which components do you put in which order and with which configuration options. That's the eventual goal. And I hope to have something to look at by next CAPC. But what Magpie mostly reads right now is U. For all of the reasons I just stated. We're committed to doing this. We're basing our business on this. But to get to that nirvana of, a fully configurable, hands-off REST development interface, I can't do it by myself. Chris and I can't do it by ourselves. Tamara, there just aren't enough hours in the day. There's Magpie, and then there's the stuff we do with Magpie. And let's face it, a lot of you guys are a lot smarter than I am. So I would rather have you in the boat, paddling along as opposed to working at cross purposes. So, if my experience with talking about this with people is any gauge, about 50% of you are like, yeah, okay, another framework, whatever. Another, 40% or so are like, yeah, that seems cool. I'll, check back when the docs are better. And then, about 10% of you are having the band moment. If you find yourself having the band moment, please tackle me after this talk, because I definitely want to talk to you. And other questions? I felt like I really rushed through this, but oh, we're way over. Yeah, okay.